Hi everyone, welcome to this video. Welcome to Greatful Learner. My name is Deepak Kumar and today's our topic is water supply engineering. So आज बेसिकली हम आज पढ़ने वाले हैं वाटर सप्लाई इंजीनियरिंग के बारे में। जो इस वीडियो में जो कंटेंट्स होंगे थोड़े वीडियोस लंबे हो सकते हैं, होप आप बहुत कुछ लर्न करेंगे। जो कंटेंट्स होंगे वो होंगे वाटर डिमांड्स, देन वाटर क्वालिटी पैरामीटर्स, देन ट्रीटमेंट ऑफ वाटर, देन डिस्ट्रीब्यूशन सोर्स एंड कन्वेंस ऑफ द वाटर। ओके, नाउ water supply engineering. So basically chapter 1 water demand. To design a water supply scheme we must first estimate the population for which the scheme should be designed. So basically यहाँ पे water demand मतलब water के demand किस तरीके से होंगे तो डिपेंड करेगा population, how much population कितनी है उसके अनुसार हम water demand and water supply की चीज़ें करेंगे. Then the schemes installed must cater for the demand of protected population and of the predefined future date. ओके, नाउ द यहाँ पे डिजाइन एक पीरियड बताया गया है. डिजाइन पीरियड एक्सप्लेन करी गई है कि वाटर सप्लाई स्कीम इंक्लूड्स the huge and costly structures such as reservoirs, dams, pumping units, distribution system, etc., and the which can be not be replaced or increased in their capacity easily. Okay, now the various components are designed such that future needs of the community get satisfied. This future needs is called design period. Is the water demand supply. It involves all the things, and the design period should be neither too short, no too long. Okay, now the storage span, the intake work, the pumping, the pump set, and the water demands units. Okay, now the water demand. So basically domestic water demand, water required in private buildings for drinking, cooking, gardening, etc. एक्स्ट्रा ये हम वाटर डिमांड यूज़ करते हैं. GOI मैनुअली लेज अलाउंड डे आउट वाटर कंजप्शन बिटवीन 135 LPCD to 225 LPCD मीन्स लीटर पर कैपिटा पर डे. मतलब इसका मतलब ये हुआ कि 1 डे में लीटर पर कैपिटा पर डे. एक दिन में कितने कमर्शियल बिल्डिंग्स में जो उसके पर्सनल यूजेज है, कुकिंग है, गार्डनिंग है, उसके लिए वो कितना वाटर डिमांड की रिक्वायरमेंट उनकी है. अंडर ऑर्डिनरी कंडीशन मिनिमम डोमेस्टिक वाटर रिक्वायरमेंट फॉर अ टाउन विथ फ्लशिंग एंड सिस्टम should be taken as 200 LPCD liter per capita per day for low incomes and LIC demand. Okay, now the commercial institutional water demand. So basically on the leverage per capita demand of 20 LPCD is usually considered to be the enough to meet commercial and institutional demands. Now the for highly commercialized cities this value is taken as 50 LPCD. Okay, now the in cinemas and theaters demand is should be the increases approx 15 LPCD. Okay, now the water demand, industrial water demand. इंडस्ट्री में किस तरीके से डिमांड करेंगे तो इंडस्ट्री वाटर डिमांड रिप्रेजेंट्स द वाटर डिमांड ऑफ इंडस्ट्री विच आर एक्साइटिंग फॉर लाइकली टू स्टार्टेड इन द फ्यूचर्स पर पेपर इंडस्ट्रीज फॉर 1 ton to paper production 200 to 400 liters of water is used. Okay, now the for petroleum refinery used to the miles which 1 to 2 liters of water. Okay, now the water demand for public use. This includes the things the requirements to drinking and etc. The nominal amount for non-existing 5% of the total consumption of city is provided as demand for the public uses and public places. Also for public use 10 LPCD is considered. Okay, now the water demand in fire demand. फायर में किस तरीके से जो वाटर की डिमांड होती है वो किस तरीके से करते हैं. फॉल बेसिकली हम अभी वाटर सप्लाई इंजीनियरिंग करते हैं. वाटर किस तरीके से सप्लाई करती है बेसिकली एक तरीके का इंजीनियरिंग है, राइट. तो ये फायर डिमांड में हम वो चीज़ें को समझेंगे कि फायर डिमांड में किस तरीके की चीज़ें और इवेलुएट करती है और इवेपोरेट करती है, और वो चीज़ें हम समझेंगे. 3 जेट स्ट्रीम्स आर साइमल्टेनियसली थ्रोन फ्रॉम ईच हाइड्रेंट, वन ऑफ द बर्निंग प्रॉपर्टी, वन ऑफ विच इज एडजेसेंट प्रॉपर्टी. ओके, now the discharge in each and not be less than 100 liter per minute. Okay, now the minimum head available, this one is right. Then the fire demand which was the 50,000 the water demand required the things, and this is the closing formula. Fire demand Q is equal to 3182 root under P, where the PP is like what is the consumption of the water, and the Fairman's formula like is equal to something when population P population. Okay, P population. So national board of the underwriters formula, then the Bushnell formula. So we have to conclude the fire demand. Okay, now the per capita demand. Which one per capita demand is the average amount of the daily water required one person and includes domestic, industrial, commercial, public use. That for it is for its Q is equals to the total yearly water requirement of the city divided by the population to 365 days. You have to fine tune the average annual amount of daily water with the water demand supply, and the factors affecting per capita demand is the size of the city, the climate, climatic condition, then quality of water supply, then pressure in distribution system of supply. Okay, now the various types of demand for design. The maximum daily demand is 1.8 to average daily consumption of water. Okay, now the maximum early demanded, the maximum peak demanded, and the 1.5 into a maximum daily demanded, and the 1.5 into this one is equal to 1.5 into 1.8 q average daily consumption. Okay, now the design capacity of various component of water supply, then the when is the dam is reservoir, then इसके बाद वाटर ट्रीटमेंट प्लांट्स करते वाटर ट्रीटमेंट करती है, देन प्लम्बिंग यूनिट्स में जाती है, देन प्लम्बिंग यूनिट्स में जाकर के फिर आगे सर्विस रिजर्वायर इज डिजाइन फॉर डेली कंजप्शन, देन उसके बाद डिस्ट्रीब्यूट करती है, राइट। सोर्सेज ऑफ सप्लाई में भी डिजाइन फॉर मैक्सिमम कंजप्शन, द पाइप मेन्स दैट मेक्स वाटर फ्रॉम सप्लाई टू रिजर्वायर फ्रॉम द अदर ट्रीटमेंट्स, तो किस तरीके से एक चेन बना हुआ है, राइट। डैम है, वहाँ जमा हुआ, देन ट्रीटमेंट करती है, देन प्लम्बिंग यूनिट्स में जाती है, फिर वहाँ से डिस्ट्रीब्यूट करती है। ओके, so quality parameters of water, the properties that certain qualities of raw water are termed as quality, and then the parameters, and the water impurities are classified as physical, chemical, and biological, you know very well. Now the quality parameters of water, the physical quality parameters, suspended soil, for suspended soil as per environmental protection agency, the maximum permissible 30 gram per 30 milligram per liter of drinking water. Okay, now the quality of water, so basically the turbidity, the measures of extent quality is either absorbed for a scratch suspended matter in water, then the it objectable because so basically aesthetically disappearing, it provide absorption sites for chemical and biological agents, thereby reducing the efficiency of the treatment. Okay, now the quality parameters of water, physical quality parameter, turbidity measures for turbidity is done by the turbidity rod, Jackson turbidity meter, it's like instruments, then Bailey's turbidity meter, then the nephrometer. It is the water quality meters, measurement of turbidity measures are there. The platinum is at the 100 dimensions. Now they are the needed. So how to check the physical quality parameters? Okay, now the turbidity measure of it is done by the turbidity rod. So basically we have eyes, we have C and the rod of the functions, the graduations are encrypted in rod ppm parts per million, and at the depth of the injection increase in the reading, the turbidity which 1 mg of silica produces 1 liter of dissolved as taken as 1 liter. The quality parameters of water, one with physically parameter quality and the turbidity, then the Jackson turbidity water levels of water is increasable ms of flame if disappears, and this method is 20 ppm. Now the glass guaranteed to 20 ppm. Okay, now the quality parameters of water, then the turbidity, then the ballast turbidity meters, turbidity is the nephrometer, is the instruments names, and the turbidity less than 1 ppm parts per million, 10 raised to 6 we have conclude in solute solvent solution, like solute. And the show most widely used for domestic supplies, unit in nephrometer is NTU, nephrometer turbidity unit, and the similarly JTU for Jackson turbidity meter. Then the expectable limits for turbidity 1 mg per liter, or over NTU is what? NTU is nephrometer turbidity unit. Okay, permissible unit 5 mg per liter, and the cause of the production. Okay, now the physical water quality parameters, its color. So color is produced by the suspended matter and dissolved water, true color, dissolved solids in the red color, suspended solid, and the white color is expendable. Iron oxide gives a reddish color, magnesium oxide gives brown and black color. We have checked the different physical quality parameters of the water. Okay, now the humanic acid equal to yellowish brown color, and the color is measured by thermometer, and result is expressed in 3 color units, and this one. Okay, now physical water quality parameters, tested and odor caused by chemical and dissolved like H2S, methane, and it is industrial of all the things. Okay, now the taste and odor measured at instrument known as oscilloscope, intensity of the measuring threshold water under condition, T1 is equal to threshold order number, A is equal to volume of the odorous water in ml, V is equal to water of odor free, and require this GOI recommended on 1 or 3. Okay, now the physical quality parameters, that will be temperature with the biological chemical reaction. So for quality of water supply, it just between to 10 to 20 degrees centigrade and greater than 25 degrees centigrade objectionable. Okay, now the chemical parameter, how to check the chemical parameters. The first one is absolute dissolved solid, then pH, then clarity, then hardness, then chloride content, then nitrogen content, then phosphorus, then fluorides, then metals. Each are the chemical parameters which are the physical quality parameters of the water. Okay, now the chemical parameters. So dissolved solid is GOI, manual requirements appear in limit as 500 mg per liter. Okay, now the casual rejection 2000 milligram per liter. pH is H plus, Al is equal to alkalinity is 6.5 to 8.5, and the pH can be measured by colored indicators, the methyl orange and the phenolphthalein. Okay, now chemical parameters we have changed the metals. Metal is the iron, magnesium. We have the tables which have included the things, the magnesius, then copper, sulfate, zinc, arsenic, cyanide, the mercury. Here the extreme limit, the cause for rejection, the comments. Okay, now methods of treatment, the screening, aeration, sedimentation, coagulation, population, filtration, degenation, other methods. These are the methods of treatments. एक हम स्लाइड में हमने देखा था कि एक लाइक डैम से क्या होती है कि ट्रीटमेंट होती है वाटर का। तो ये प्रोसेस है ट्रीटमेंट वाटर का कि स्क्रीनिंग होती है, देन एरिएशन होती है, देन सेडिमेंटेशन होता है, देन कोगुलेशन होता है, देन फोकुलेशन होता है, देन फिल्ट्रेशन होता है, देन डेजनिफिकेशन होता है, देन अदर मेथड्स फाइन ट्यून करके हम वाटर को अच्छे तरीके से फाइन ट्यून करते हो। मेथड ऑफ ट्रीटमेंट स्क्रीनिंग में क्या करते हैं, तो सिर्फ स्क्रीनिंग इज डन टू रिमूव द हैवियट सस्पेंडेड इम्प्योरिटीज फ्रॉम वाटर लाइक प्लांट्स, स्टोन्स एंड एनिमल्स। ओके, नाउ द स्क्रीनिंग इज जनरली ऑपरेटेड विद द हेल्प ऑफ टू टाइप्स ऑफ स्क्रीन, द कोर्स सिरेंज, द फाइन सिरेंज। ओके, कोर्स सिरेंज, so basically the code range is the bars of dia 25 mm and spacing 20 to 100 mm, and spacing these screens are generally placed 3.6 vertical to 1 horizontal. ठीक है, देन फाइन स्क्रीन्स में आप देखेंगे कि दीज आर जनरली इन द फॉर्म ऑफ वायर बेस ऑफ साइज 10 mm, एंड द फाइन स्क्रीन इज जनरली अवॉइडेड एज इट गेट्स frequently and requires as the sort of the things. Okay, now method of treatment the aeration. So aeration to remove the gases like H2S and uh, H2S and CO2, and the aeration add oxygen to water to carry out the oxidation of the undesirable substances like organic matters and ions. Now the reaction also remove phenols, humic acids from water like Fe3O2 plus. They are the the aeration process. Okay, now the methods of treatment. So sedimentation. So sedimentation is a natural process by which solids with higher density than he fluid in which they are suspended settles under the actions of gravity. Now the sedimentation tank is used to remove suspended solids. Okay, now the is it the Stokes law, which is equal to G to Gs minus 1 radius square, battery V is kinetic viscosity, it's the its unit is meter square per second, and the specific gravity of particle, then D is equal to diameter of particle. Then method of treatment, third method sedimentation. Sedimentation कैसे होता है? Sedimentation is two of types. First one is quiescent type, then the continuous type. So quiescent type. Quiescent type has a detention or time of 24 hours and cleaning interval of 8 to 12 hours. Okay, now the tank is designed by maximum daily flow. Okay, now the method of treatment. So basically the coagulation, the efficiency of sedimentation is very less when where water contains very fine suspended solid, hence to improve efficiency coagulation is done along with sedimentation. Okay, now the coagulation is a process in which certain chemicals known as coagulants and added in the water as to neutralize and the charges of the particles, so that the particles can come together to increase efficiency. A certain minimum amount of energy required for this process known as the threshold energy, which is provided in the coagulation process by including the rapid mixing in the water. So for the entire process of coagulation is carried out in three steps, like coagulation fast fixing, then coagulation slow fixing, then sedimentation. Okay, now the measure of treatment of coagulation. So different types of coagulant used are like L2SO3, L2SO4 whole thrice into 18H2O, then coppers have two different type of coagulants used as the chlorinated coppers, then sodium, aluminum, then lime. Okay, now the methods of treatment of coagulation. So the aluminum, this process adds hardness the water due to calcium sulfate, and increase acidity water due to carbon dioxide. If alkalinity is not present, then the external alkaline agents like lime and soda ash are added to induce artificially alkalinity. Okay, now the method of treatment flocculation. So basically in flocculation, utilized suspended particles are removed with sufficient contact time so as a combined raw incisor get finally removed in the sedimentation process. So sedimentation process में होता क्या है कि flocculation होता है, न्यूट्रलाइज सस्पेंडेड पार्टिकल, न्यूट्रलाइट जो सस्पेंडेड पार्टिकल्स होते हैं उसको क्या करता है, एज ए सफिशिएंट कॉन्टेक्ट के साथ उसको क्या करता है, रिमूव, फाइनली हम रिमूव करते हैं, देन सेडिमेंटेशन प्रोसेस विथिन इन ऑर्डर टू द contact between the neutralized particles was bigger the size flux socks which is done. Okay, the flocculation depends on the turbidity. What turbidity is more turbidity, more will be flocculation. Okay, type and dose of coagulant, iron coagulant will remove flux in less time. Okay, now the temporal mean velocity gradient, these are the method of treatment. Okay, now the method of treatment, filtration is the most often used as the limited steps to remove the flux and fine are used to make particles through the beads, garnier, the materials. Filtration also removes certain organic matters like microorganisms and dissolved minerals from the water. Now the two types of filter are used, the gravity filter, the pressure filter, the two filters are used here. Okay, now the filtration, gravity filter. So basically there are the types of the filter in which used is required for water to pass through their medium, pass through the filter medium. This head is provided by height of water itself and over the filter medium. These are two types of filtration, like slow and filters, rapid sand filters, slow sand filters. So pressure filters, basically these are the types of filter in which head required for water to pass through a filter medium is provided artificially by the application. Okay, now the filtration. So gravity filters, slow and filters, effective size of the sand particles is taken as 0.2 to 0.3 mm, and the here mentioned is that the top of sand layer is equal to depth and the sand layer, and the coefficient of infallibility cu is equal to this one. The design of the filters 10 to 15 years, and the frequency of these are the sand, gravel and support. These are the process to filtration. Okay, theory of filtration. So basically mechanical staining, the sedimentation, the biological changes, then the electrolytic changes. So basically the mechanical staining, impurities greater than the size of the filter are filtered. Filter means बाहर निकलती है, filtered उसको करते हैं, छन्नी करते हैं. Sedimentation, turbulence removed from water during filtration, hence suspended particles to other particles. Okay, now and the slow sand particles. So number of filters required, the treatment depends on the filters, like area. Here are two charts, there are areas and the number of filters. Okay, so less than areas is 2 including one susceptibility 20 to 49, 25 to here the charts, slow and sand filters. Okay, now the chlorination. So basically immediately reacts the ammonia present in the water of the form chloramines. The chloramines are combined from chlorine and are less effective than freely available. Duration in the casual chlorine treatment in the pH is kept between 5 to 7. Disabolization is the present, and the dose of chlorine should be sufficient as to leave 0.2 mg per liter of the chlorine and the things like that. Here is the formula of chlorination. So chlorination form is chlorine is added for as for free chloride, bleaching powder of hydrochloride, CaCl2, calcium oxide chloride, the chloramides, calcium oxide. Okay, now the sources of water, infiltration gallery, infiltration wall, then the springs. Horizontal tunnels constructed at a shallow depth along the river through water bearing strata. These also are called as horizontal wells. These are shallow wells constructed in series along the banks of a river in the collect of the water. Okay, now the water distribution convey and its source. The method of distribution, the system of supply. Water the method of distribution is given here: gravitation system, pumping system, combined system, and the supply system of supply, continuous supply, intermittent supply. Okay, now the water distribution conveys under layout of distribution system. The distribution pipe system consists of mains, sub mains, laterals, branches and service connection. Okay, now the distribution pipes are laid along the roads or below footpaths depending upon local condition. There can be several types of streams. Now the water distribution conveys the things on the layout of distribution systems. The dead in systems, three systems the used for old towns where houses are in unplanned way, and it is easy to design, it's cheap and simple, and the branches the lateral submens disadvantage. So basically the water can reach a particularly point and only through one route, hence its fault occurs at it flows the things. Okay, now the layout of distribution system, grader iron flow, it is also a reticular system. One main pipe runs through center and branches and lateral run in grid patterns which are interconnected to each other. And the advantage of the layout of distribution system, the advantage of layout of distribution system is dead ends and eliminated. Then at the time of fire, water can be separated. The disadvantage design is a bit difficult. Size of pipes and larger and more number of valves are required. It's more suited plan and city only. In the convey, the conduits for water supplies is the gravity conduits and the pressure conduits. Okay, now the gravity conduits, water flows under the action of gravity flow. Gravity flow can occur in pipes, canals and liquids of flumes. So pressure conduits, water flows under pressure above atmospheric pressure. These pipes are commonly used. Okay, now the convey, then metallic pipes, the cast iron pipe, the steel pipes, water pipes, the non-metallic pipes, the RCC pipes, the pre-structured concrete pipes, the express pipes, these are the conveys to water flow in a which in a direction. Okay, now the joints is pipelines. So SPI joint, it is also called Bell and SPI joint, SPGOT joint, socket pipe, SPGOT pipe. That is used to connect was iron pipes and steel pipes. Okay. Now the color joint, it is used for joining RCC pipes, Winard epsilons. Okay. Now thank you so much. ये वीडियो थोड़ी सी लंबी हो गई है होप यू आर एंजॉइंग दिस वीडियो। इस वीडियो में आप बहुत सारी चीज़ वाटर सप्लाई इंजीनियरिंग के बारे में आपने सीखा होगा कि वाटर एक जगह एडजॉर्ब्स होता है, देन उसका प्रोसेस होता है, उसको फिल्ट्रेशन का जो डिफरेंट डिफरेंट टाइप का कैटेगरी हमने पढ़ा है कि किस तरीके से उसकी फिल्ट्रेशन होती है, राइट। देन उसको फिर पाइपलाइन से एक तरह से एक जगह एब्जॉर्ब किया जाता है, देन वहाँ से डिस्ट्रीब्यूट करा जाता है, राइट। तो वो चीज़ें हमने पढ़ी। होप ये वीडियो आपको अच्छा लगा वाटर सप्लाई इंजीनियरिंग का। ये वीडियो आपको अच्छा लगा हो प्लीज़ लाइक शेयर एंड सब्सक्राइब जरूर करें और आप अपने दोस्तों को भी ज़रूर शेयर करें। फिर हम मिलते हैं एक नए वीडियो के साथ, एक अच्छे वीडियो के साथ। थैंक यू सो मच, थैंक्स फॉर वॉचिंग दिस वीडियो, थैंक यू।